Okay, let's do that now. Okay, let's place the egg on top.
That didn't work. Here's take 2. And here's take 3.
So on take 3, you can see what happens. Now, the nice part of this demo is that we can actually get the egg out again by using the same trick. Did you work out why the egg went in? It was because when we dropped the paper in, the temperature inside the flask increased a lot. The pressure is still atmospheric pressure. The volume of the flask is set. So when the temperature increased, the number of moles in the flask had to decrease. We then put the egg on. At that point, the paper had gone out, and so the temperature inside the flask started to decrease. The pressure now changes because the molecules are not free to move in or out of the flask, and so the pressure inside the flask actually decreased, while the pressure outside was still at 1 atmosphere. Because we had a greater pressure outside than inside, it turned out that there was a force pushing the egg down into the flask. Now what we're going to do, we'll just quickly clean out the flask, but leave the egg in there. And then what we can do is blow into the flask to increase the pressure inside the flask. And if the pressure inside the flask is then greater than the pressure outside, the egg should come out again. So that first part was a nice demonstration of Gay-Lussac's law. You saw that as the temperature inside the flask decreased again, the pressure decreased as well. Now hopefully this is going to work. This egg is now acting as a valve, so it should let me blow into the flask, and it should then stop the air molecules escaping again, increasing the pressure inside the flask. You can see the egg slowly coming out of the flask now. Here it comes. Oh, yum. We can have egg for lunch now.